Welcome to today's webinar, 7 Signs of Data Center Network Transformation. My name is Kate Lehman, and I will be your host for today's webinar. Joining us is Prashant Gandhi, VP and Chief Product Officer here at BigSwitch. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you are watching this video in a rebroadcast or a recording, or you have questions on an upcoming webinar topic that you would like our panelists to address, email us at info@bigswitch.com. We have also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. We have a full agenda for today's webinar. Let's get started. Prashant, I'll hand it over to you.
Great, thank you, Kate. Hello, everyone. Thanks for joining this very interesting webinar where we will be talking about data center network transformation. And the question that comes up when we talk to IT organizations and data center operators is this transformation real? We have been talking about transformation for many years now. So is it underway? What is the status of this transformation? So what we felt we should do is to highlight the 7 signs that clearly indicate that this network transformation for data center is underway. And so the question is, what are these 7 signs? And that's what this webinar is all about. So let's start with some context. What have been the challenges in the data center? Data center has been in existence for past 20, 25 years, leveraging modern technologies. So why challenges with networking? Why is networking not getting modernized? And the question is not the one that is being asked by only the users, but also data center operators, right? So here is a very famous talk a few years back, 2009, by James Hamilton at Amazon Web Services, AWS Cloud, that data center networks are in my way. And that really has started the conversation that a transformation is necessary for data centers. And the challenges that we see clearly are that we are using an interface that's very legacy interface of the 90s. I mean, if we look at compute and storage, they're modernized significantly. They're no longer in the 90s era. We still do provisioning of network switches and routers on a manual box-by-box basis. Clearly impacting the velocity that is needed for today's data center, modern data center that needs to operate at the speed of the cloud, speed of the VM and containers. The complexity of managing everything box by box, troubleshooting, hopping and hunting, doing show commands to try to figure out and correlate where the problems are, constant provisioning that is very hardware centric and hardware defined with ports and sub interfaces and VLANs and VRFs. It's just not easy. It takes a lot of time, and network operators are just running around every day, just trying to keep the lights on. They have no time to think about innovation. How do they bring value to the business, the way compute and storage folks are doing? And that's just not the right way to go. And clearly, the entire ecosystem is very proprietary, closed, expensive. There is no choice, and many operators see that they are really under the control of the supplier. And so where do they want to go? They really see that their mandate in the data center is to drive towards hybrid cloud, where their workloads can reside in public clouds, they can reside in on-prem environment, depending on the need of the workloads, and be able to do this at cloud speed. The question then becomes is, how do they get to that cloud speed? And that's really what we are going to discuss today. The speed that they are looking at is speed at the at the speed of the VMs, at containers, the way clouds are operated, at instant notice, at the moment's notice. They'd like to also reduce expense in the data center, both in terms of CapEx and OpEx, and certainly would like to see the vendor choice. So if you look at a customer perspective, right, what they would like to do is to, bring up new services, new applications very quickly. The speed of service enablement needs to be, very, very high. And reduce cost. I mean, these are very important characteristics that the operators are demanding in the data center. So then the question is, what happened? Didn't we do amazing innovations in networking a couple of decades ago? If we go back to the 90s, the network was leading the innovation wave. The TCP/IP stack, Ethernet and IP, were the drivers, and they brought tremendous innovation, tremendous speed, tremendous cost savings, integrated into a multi-service data network that carried also voice and video. And that was tremendous benefit to all IT organizations, service providers, and enterprises. But as we entered into the Web 2.0 era, the network became a big challenge. And here, the legacy first mindset remained, bringing in complexity, bringing in the slowness that we experience today, along with very high prices. And so what happened was that it's not that innovation stopped. Innovation continued, but by the cloud operators, the cloud giants, the hyperscale organizations. And they are the ones who have been innovating for the past 10 years. And so as we usher into the cloud era and the edge computing era, it is important that we bring the network to the same level of innovation. And so this talk today, we will be talking about principles that are innovations in cloud principles, and we want to use them as first principles in modernizing the data center, transforming the data center networking architecture. So we see that there are 7 signs, and each of these signs, as we go through, we will see that they're inspired by innovations in the cloud, and we want to inherit these innovations and bring them to for the benefit of mainstream organizations, mainstream enterprises, and mainstream service providers. Now, when we talk about innovation, it is very important that there is a level of qualification for that innovation. So the metric we are going to assign to innovation is as follows. It has to be a technology or architectural construct. It can't be anything but a technical entity. It has to be revolutionary. I mean, there is always evolutionary incremental improvements that continue to occur, but we want to kind of look at really black and white before and after phenomenon. And finally, it needs to have market traction. We can think about many ideas all day long, but unless we have market traction, customer adoption, necessary footprint in the industry, the innovation, the consumption of innovation is not there, and therefore it is out of scope for this discussion. Okay, so let's start with sign number 1, open networking.
And before we jump into sign number 1, open networking, we have a quick audience poll. Which of the following does your organization believe in regards to openness? A, it is a mandatory requirement. B, it is very important. C, it is somewhat important. Please select the choice that most appropriately identifies with your organization. Okay, according to our audience, 43% believe it is somewhat important, and we have a tie for it is very important and it is a mandatory requirement at 29%. This actually sort of aligns with Gartner's recent research and survey audience. So, Prashant, over to you.
Fantastic, thank you. And throughout this this webinar, we will be, for each sign, we will be doing a poll just as a way to kind of get the user feedback in regards to these innovations. So this is very great feedback. It looks like 60%, super majority, are interested or in open networking in the sense of it's mandatory or very important. So that's fantastic. So let's kind of put some context. Why open networking? Well, if we look at compute, this question does not arise. Mainframes were proprietary and closed systems, very expensive. ASIC, hardware, software, everything packaged into one environment. And we saw a tremendous revolution in disaggregation of the mainframe into x86 architecture, industry standard, can purchase servers from anywhere, and then run applications and operating systems on it. And that led to a disaggregated stack, as we see on the right-hand side. You have choice of ASICs, choice of hardware, and the choice of operating systems and applications on top, choice of software. And what happened was that tremendous amount of innovation took place once the stack was disaggregated. Each layer of the stack, innovations occurred. You didn't have to depend on the other layer in order to innovate. So hardware innovated, ASICs innovated, applications innovated, OS innovated. And you didn't have to re-innovate the OS all the time between 7 different suppliers, each having their own OS. No, Linux is one standard, and everyone and there is continued innovation on Linux, but there is no need to have another open source operating system, for example. And so innovation occurred where it was needed, and a lot of the innovation moved up stack, which is what we witness today, including large public clouds which are built on this disaggregated principle of computing. So what about networking? Well, mainframe of networking, call it a net frame. It remains very proprietary. Oftentimes, even ASIC could be custom or merchant, but the hardware and software are very closed. And so why not disaggregate the stack? And this is where open networking mindset comes in, where you would use industry standard components and leverage standards as a way to disaggregate the stack. And when we do that, we see that you can have choice of hardware and choice of operating system in networking. Now, cloud guys led this innovation. Google had their switch in 2012, the Pluto project or Pluto switch or Google switch, which was an open switch, which ran Google software, Google OS, and that led to massive activity in the ecosystem and ton of innovations over the last few years, where there is a variety of hardware, open hardware, and software available on this disaggregated ecosystem. In fact, there is a prediction by a variety of market analysts that says, that open networking or bare metal switches will reach a quarter of the port shipped in the next few years. So there's tremendous appetite to go disaggregated in mainstream data centers, and we are witnessing that in our own customer environments who are deploying open networking switches in large scale. So leveraging this cloud principle as first principle, what Big Switch has done is to provide 2 solutions leveraging disaggregated systems: a data center switching fabric, the cloud fabric, and a data center visibility fabric called Big Mon or Big Monitoring Fabric. They leverage open networking switches from Dell EMC, HPE, as well as EdgeCore Acton, and all speeds are available with a lightweight operating system. The NOS also leverages open source components such as ONI bootloader and Open Network Linux, and both of these are open sourced and open source projects in Open Compute Project OCP. So, and we see one of the examples of customer benefiting from this solution and CapEx affordability. It's a clear advantage of open networking, that can be realized day one. And of course, the choice of hardware. One can deploy different applications leveraging different hardware, more optimized for each application.
All right, before we jump into sign number 2, we're going to do a quick audience poll. Now, it's no secret that is your organization on a path to implementing web scale initiatives in order to achieve higher levels of scale and automation and to also better manage risk? According to Gartner, it estimates that 40% of global enterprises will have web scale networking initiatives by 2020. Gartner's Andrew Lerner states that the general consensus is that 99% of what hyperscalers do has no applicability in the mainstream data center due to their scale, the people or talent, or the corporate appetite to drive technology and information. However, in their research, they found that it's become clear that a number of these principles can and must be applied to enterprise data center networks. Let's take a look at the poll results. Is your organization on the path to implementing web scale initiatives to achieve higher levels of scale, automation, and better manage risk? 75% of you said yes. All right, over to you, Prashant.
Perfect. Looks like, cloud force is in the air.
It is indeed.
So let's assign to look at, assign 2 is really focused on core and pod architecture, What does that mean? It means that if we look at what we have today, which is really a multi-tier edge aggregation core architecture, there is a variety of complex protocols, layer 2, spanning tree, complex configurations, hard to troubleshoot, is the architecture today. And that is a very traditional approach that brings a ton of complexity. There's also predictability problem where conversation between a source and destination can have a variety of paths, making it unpredictable in terms of latency and performance. And what the cloud giants have done is to really make this a very scale-out architecture. This is typical of cloud architectures. It has to be scale-out. It has to be open. It has to be software controlled. And these are the signs we'll go through. So each deployment is deployed as a cloth fabric, leaf and spine, and deployed in a pod-centric manner. So each pod is independent of the other pod, and it connects to a core router using layer 3. So all the pods are connected, but you could have different pods of different versions with different vendors within the pod that is somewhat autonomous from other pods. And this allows one to add new pods at rapid pace, continue to innovate as you change different versions or newer versions of the pod, and also easy to retire pods by simply removing a pod and disconnecting it from the core. And so this has allowed data center operators, or cloud operators, I should say, bring in their brownfield data center environment, continue to bring innovation at a very rapid pace. And we have seen how they add applications and continue to innovate, leveraging such scale out and fungible infrastructure. Here's an example of Facebook's ALTOONA data center design. And there's a talk and a big blog on this from Facebook. And they've leveraged, as a unit of their deployment, a sample pod architecture, which has 48 leaf switches and four spine switches. And this gets built into a multi-tier BGP fabric for a very scale-out deployment in the data center. So pod-by-pod deployment brings tremendous value in modern data center. And this is a principle, or a cloud principle, that is very important to be brought into mainstream data centers. And Big Switch, for example, provides a cloth fabric. It's called Big Cloud Fabric, as I mentioned earlier. And it is deployed as a cloth fabric in a pod. And one can deploy multiple pods, one at a time, along with legacy infrastructure in a data center, and simply connect it to core router. So very easy to consume this cloud-inspired technology today and modernize the data center. On to slide sign 3.
Yeah, so about a decade ago, cloud giants found out that software controls are critical to make the underlying hardware networking infrastructure logically centralized. So our third sign is software controls. And before I hand it back to you, another quick poll. Which of the following factors is the primary motivation for your organization in considering or implementing SDN in the data center? Please select all that apply. To bring more visibility to your environment, to lower CapEx costs, to you need a network that's more automated and programmable to support private cloud, or to improve security policy management in the data center. So IDC Research also asked the same poll recently to their audience, and they found that the leading factor for deploying SDN in the data center was to make the network more automated and programmable to better support private cloud. Let's see what our audience has said. Okay, that's in line with what IDC found as well. Prashant, back over to you to jump into software controls.
Excellent. Software controls is super important because, as the poll has indicated, it brings simplicity and automation. And we'll talk about those specific items in the next, this sign and the next sign. What happens today? Today we have a box-by-box network, very complex to manage. Sometimes, it is a central management entity is leveraged to manage these devices. What we have seen in networking over the last 20 years is that anytime you have centralized network management, it also impacts the overall scale. And typically it's after the fact, so limited in features, and also lags when new releases come out in terms of its support for features. So what has our cloud giants done? If you look at Google's Project Jupyter, really they're focused on open networking based on merchant silicon. They've leveraged class topology, class fabric, leaf-spine fabric. And finally, third important component here is leveraged hierarchical control plane, specifically an externalized controller that implements an important aspect of the control plane, and in the form of an SDN controller. And so what does the topology look like? So there are really two options in the way software controls are deployed. And there is there has been historically a ton of confusion in terms of what software controls are and what software-defined networking is. And so we wanted to highlight the two important aspects of it. Also, it's important to note that what we are discussing here is primarily physical networking, and SDN also has implications in regards to overlay networking, and that's not the topic here. Here we are focused on really physical networks. So applying software controls to physical networks, there are two options. One, you can get partial benefits with a controller that focuses on externalizing policy management on operations. And certainly this gives a whole bunch of benefits. However, it is important to note that when a policy controller is deployed, the network control plane is not externalized. What do I mean by that? What I mean by that is that if we have a BGP running in the fabric, and let's say we have 100 switches in the fabric, then there will be 100 BGP instances. In other words, the control plane is fully distributed. Only the policy management and operations are centralized. Now, if you look at a more comprehensive software controls, then part of the network control plane is also externalized in the form of a network controller. So now you have a policy controller and a network controller. Often the two can be part of the same entity as a unified external software controller. In this case, the control plane is split. There is a part of control plane on the switches in terms of a thin operating system, and much of the control plane is externalized in the network controller. And so the benefit here, additional benefit, is really simplifying the the actual fabric and forwarding plane. So now, if one has 100 switches in the fabric, there is only one BGP instance. This makes the fabric very responsive and easy to manage once a network control plane is externalized. So in both cases, we have hierarchical controls. Some controls are external and some controls are on the switches, but nonetheless, having a controller-based system is a very important aspect of network transformation. And so leveraging this cloud principle as first principle, Big Switch has applied this concept with an external controller across both its solutions, the switching fabric and the visibility fabric. And the entire solution leverages open networking hardware, cloth fabric, core and part design, and it's controller based. So all of the science that we talked about are implemented as part of the Big Switch solution. Now, let's look at some of the management and operations challenges that need to be addressed with a externalized software controller. So let's look at installation complexities, right? Adding a switch, cabling checks, fabric formation, onboarding new switches, MLAC configurations with servers, server to leaf configurations. All of these are installation and change management complexities. Other operational complexities, looking at performance, congestion, drops, outages, upgrades. So all of that needs to be addressed, and this is where operations and policy and management controllers play a big role. And here are some of the examples of benefits that we see. For example, operating a Big Switch fabric, Big Cloud Fabric. If you add a switch, leaf or spine, it's a one-click operation. Just install, power up, cable, and walk away. There is no need to do anything when it comes to fabric formation. As switches are added, they form the leaf spine fabric, zero touch. Upgrading a large fabric of up to 140 switches, it's 3 clicks or 3 steps, and within 15 minutes. Multicast, 1 click to enable multicast, fabric-wide. And if you want to do any tracing across the fabric to check whether a source is able to connect to a destination, all one has to do is simply do 1 click and get the entire trace on the fabric. So very easy to obtain speed and simplicity when software controls are deployed. Now, software controls have 2 benefits. One is operational simplification, and then the next one is automation, which is our 4th sign.
Yes, automation. It is crucial for any enterprise trying to stay ahead of competitors, right?
Absolutely.
All right. So we're going to jump into our next poll. The question is, what workflows would you like to automate? And please select all that apply. Zero-touch switch onboarding, zero-touch server-to-leaf switch MLAG configuration, zero-touch trace for troubleshooting, zero-touch network provisioning when VMs or containers are instantiated, or zero-touch software upgrades for up to 128 rack fabrics. And let's take a look at the results. Prashant, what do you think is going to be the top answer?
I'm not going to guess.
All right. 100% of you said zero-touch fabric trace for troubleshooting. Additionally, zero-touch network provisioning when VMs or containers are instantiated. Is that surprising? Makes sense?
It makes a lot of sense because day 0 is one time onboarding, but day 1 and day 2 are ongoing operations. And if you bring simplification, that's really where the biggest benefit is realized, right? And so troubleshooting, I mean, when application performance issue, latency issue, connectivity issue come up, it's really network is the one that gets finger pointed the first, right? And so network team has to go and say, actually prove that, whether it's a network issue or not. And so 4 out of the 5 times, it's not the network issue. And so, bringing troubleshooting, quickly to show that network is or is not the problem is very important. And certainly, compute and at the end of the day, business wants to deploy more services, so more applications, which means more VMs and containers. And in today's environment, the workloads are very dynamic because the demands are dynamic. And so they need to be elastic. And so the network can't be in the way. And so we need to, so that also makes sense that, network provisioning or essentially automation when VMs and applications are deployed is also an important characteristic. So that's really the focus of this time. And we'll start with innovations that our cloud friends have done in this area. And here is a very, sort of well-known area that Google has really focused on, which is automation. And they have in fact written a book. And this, many people look at site reliability engineering and try to really bring those principles to their on-prem data center. So at the end of the day, outside of black art, we have to mechanize and we have to automate. And that's really the cloud principles that we are going to focus on. A couple years ago, Google had a talk and they highlighted that, and they also had a paper in SIGCOMM, and they highlighted the areas where failures occur, network failures occur, and they're primarily due to change management or what they have said to be management operations activities. And so 70% of the failures occur because of that. And if you see kind of in the second chart, what are the management operations? They're upgrades, rollouts, configuration changes, right? And so how do we make this much, much simpler? And so, so we talked about the level of complexities earlier in terms of operational complexities and management complexities, installation complexities. Now let's look at app provisioning. And this is where I believe network automation really provides tremendous benefits, and specifically speed. Taking the network out of the way is really dependent on how well the network is automated. So again, two ways to automate the network. One way is for each of the networking device to connect through APIs into an SDDC orchestrator or private cloud orchestrator. What's an example of private cloud orchestrator? vSphere, NSX from VMware, Nutanix, Enterprise Cloud, OpenStack, Kubernetes in the container world, for example. And this is certainly one approach. There is a clear, obvious challenge with this approach, and that is that every box, every switch has to have a programmable NOS, which is not, I mean, that if one wants to look at, sort of programmability on a switch NOS or a network NOS, well, that's an incremental innovation, and that has occurred, and that's a very important aspect of automation. So, but when every device is connecting programmatically to an orchestrator, you have hundreds of devices in a data center pod, probably 1,000 in a data center. And when they're talking to an orchestrator, it means you have lots of API calls going to the orchestrator, which means orchestrator scalability for API becomes important. Resolving APIs and race conditions of APIs become important, and hence there can be issues. There is another approach, which is really cloud-inspired approach, where you actually connect the orchestrator to an externalized fabric controller, and fabric controller then does all of the provisioning of the fabric itself. And this way, there's only one API integration, programmatic integration, northbound controller APIs talking to the orchestrator APIs. And this becomes a very scalable, predictable, responsive way to do network automation. And this is the cloud principle that Big Switch has adopted as part of Big Cloud Fabric, which is a data center switching fabric. And the controller, which is both a policy, operations, and management controller, as well as a network controller, integrates with a variety of orchestrators. And it makes the network, from an orchestration perspective, a one logical switch. And therefore, the complexity of this environment is never more than one switch from an operator perspective. From an orchestrator perspective, it is also thinks of it as it's talking to one switch because it is only always talking to a controller as a single API interaction. And this provides tremendous automation benefits. So, for example, when servers are added, a server team or compute team adds new servers in a rack, network team does not have to get involved. The MLAG is automatically configured by the controller on the leaf switch. So when you have a hyperconverged team or your virtualization team or your container team, they can keep adding servers and the network will automatically configure itself. Fabric will automatically form, and there is really no network team involvement, which means that the network is now operating at the speed of the VM and the containers, and the network team does not have to do the menial task of setting up VLANs and setting up ports and interfaces and VRFs and so on, and keep checking across multiple boxes. So all of this, low value, sort of day-to-day work can be offloaded to the controller, which can automate these important workflows, day one and day two workflows. Another important thing is when VMs are added to the network, why should one have to configure L2 and L3 policies on different switches? Why can't the controller take care of that? And that's exactly what happens when integration is enabled, when a VM is instantiated on ESX or on OpenStack or in a containerized environment or in Nutanix hyperconverge. The L2 network and L3 policies can be immediately configured across the fabric, and the policy would follow the fabric. So, and you get complete visibility. So trust automation, but also verify automation is a key principle that is available. And like the survey we did, Kate, earlier, we've also done surveys with our customers, and 52 of them have said that they've experienced significant improvement or speed in their environment. Better than half, nearly 2/3 have said they see 50 to 75% improvement, and over a third have said that they see 75% to 100% improvement. So very amazing speed. There is a customer quote on the slide that says decreased TCO by 90% because of automation. And this is the enabler for the business, right? So this is how network team are able to bring innovation, leveraging cloud principles on-prem, and be at the innovations table with compute and storage team, and participate in bringing speed, agility, simplification, lower cost to modern data centers.
Yep, I guess we all know why we need network automation. It's definitely something that's transforming the network. For this section, we are going to do a poll at the end. So Prashant, back over to you for controller-based ACLs.
Okay, perfect. Security is very important, especially in modern times where attacks are constant, and that's a new normal, I suppose. And so how do we address security? Traditionally, security has been a nightmare. You go on every box, configure a whole bunch of ACLs, access control lists, and you have to make sure that you're not breaking anything when you're editing any one of them. And we have seen that it is very difficult to, in fact, remove an ACL because there is just no visibility in terms of the impact of that ACL has on the overall environment. So deleting it could be a challenge. So complex to write, complex to do change management, remove, very difficult to troubleshoot. How do we address this challenge? Well, let's look at the cloud guys. We'll go to our favorite example in AWS, how are security policies managed for a given tenant? Well, first of all, they're centrally managed, so you don't have to do that on different instances or different VPC containers. There are two types of policies available: subnet-based policies, which are well understood. This one could think of these as our normal, L2 or VLAN-based policies. And these are compliance friendly because, all these applications that are compliance sensitive, there have been policies written for them, audits have been done, and they have been validated. And so subnet-based policies are very, very important. And there is a new class of policies that are also being implemented, which are called security groups-based policies, where one could think of them as subnet-based policies, where you could apply security policies to specific endpoints within a subnet or a VLAN. And it's very important to have the policies follow workloads. So these are principles that cloud providers have implemented. And so how do we take these principles and make them first principles for our on-prem environment? Well, let's start with central management of controllers, ACLs. And this can only be done through a controller-based system. And so, central management occurs, for example, in the Cloud Fabric through the controller. The fact that controller manages the entire fabric as one logical unit makes it very easy for policies to follow the workload. Workload can go from rack 1 to rack 17, and the policies will follow. There is no additional, configuration or intervention required by the network or the security team. Policies are identified when you're doing, troubleshooting traces very easily, and we'll look at some examples. And one needs to add security groups to this environment. BCF as a physical fabric interoperates and integrates with Kubernetes, NSX, Nutanix, OpenStack, where security group and microsegmentation policies are defined and applied. So an example screenshot of policies are in the Cloud Fabric in the GUI are very easily created and visualized. So there is no need to go box by box here. And one important aspect of policies, in addition to doing change management, is doing troubleshooting. One of the very important care abouts in data center operations, when you're checking for connectivity between source and destination, how do you check both the fabric connectivity as well as the fact that the policies are allowing configurations. Policies are configured to allow connectivity. And here, the trace clearly would show that the traffic is forwarded on the fabric, both in forward and reverse direction, and the specific ACL that enables that to occur. And so that level of granular troubleshooting becomes, makes life very easy because it's just a one-click operation. Select source, select destination, and go. Now, if traffic is dropped, if you have connectivity issues, it also identifies that specific network policy has been activated to drop the packets. And this way, one can easily determine whether it's a fabric problem or issue on the fabric, or whether it's an issue within the compute and storage environment within the application infrastructure.
Great. Network security is certainly a fundamental construct of any data center deployment. So I think it's no surprise that you selected controller-based ACLs for sign number 5. Let's jump into our next poll. In the next 12 months, how do you see your network security evolving? Select all that apply: traditional ACL, controller-based ACL, or security groups, also known as microsegmentation. And any guesses for leading result here?
Probably the bottom two.
All right, let's see what our poll results show. 50% with controller-based ACL. Okay.
All right.
We have traditional ACL and security groups as a second place tie at 38%.
Fantastic.
All right. So,
let's move on to the next sign.
All right.
Number 6,
all
network
right.
analytics.
Yes. So network analytics are critical to rapidly identifying application performance and connectivity issues, as well as capacity planning. We're going to jump into our next poll. We had a question around your use of network analytics today. So do you use network analytics today for your operational workflows? And your options for answers are: we do not currently have network analytics. We use built-in analytics provided within our data center switching solution. or we use separate network analytics solutions outside of our data center switching solutions that we use today. And if you can select which is the appropriate answer for what your organization is doing. All right, let's take a look at the results. Any guesses?
Switches have no analytics today.
Okay, 60%. We use separate network analytics solutions out of the data center switch.
And that makes perfect sense because switches today can't do analytics. And so either you have no analytics, right, which is, so 0% makes sense. So either you have no analytics or you would have to deploy a third-party solution to get analytics out of your data center fabric. So that makes perfect sense. And that's really the sad state of network visibility. In a box-by-box network, we can't have analytics built in because the hardware is too limited. Our only option is show commands, SNMP, going through mountains of syslogs, can't have any historical information. And, at the end of the day, we have to rely on third-party expensive bolt-on tools or not have any analytics. And so those are the two options we have, and the survey clearly identified that that's the state of the industry today. All right, so let's go back and see what our cloud friends, cloud giants, have been doing. If we look at public clouds, and here we're really focused on AWS, but this is applicable across AWS, Microsoft Azure, and Google Cloud Platform, GCP. So given a tenant, which is a VPC tenant, one gets flow logs for every conversation. It's very tenant-centric, not box-centric, so it really has no implication to the physical environment. Analytics workflows are streamlined to that provides additional filtering and processing so that you can actually have the right workflows and ask the right questions when especially looking at why a source is not talking to a destination or why do I have errors in my network. And everything is centrally managed, not box by box. And these are the principles that we believe are important in any modern data center fabric. So as you're selecting such fabric, you need to ask these questions to see if one has built-in analytics. Is it fabric-wide? Can you support multiple visibility and troubleshooting workflows? Can you get adjacent domain information such as visibility to compute and storage environment, containers, VMware environment, hyperconverged environment, and can it all be managed centrally? And this is really the benefit that Big Switch, Big Cloud Fabric solution provides with built-in analytics. It's right there, built into the controller, so always available at a moment's notice. And it's very easy. It has historical time series, so captures historical data and statistics and logs. So you can look at how your drop rate is occurring. Perhaps things are going bad in the network, and here are last few days or few hours of the changes that are occurring in the network. One can go and drill down and say, okay, what interfaces are at risk? And one can look at the interfaces and the drop rate for each of the interfaces. And historically, you can see that, hey, my network was a lot better a month ago or a day ago or a week ago, but it's having issues. So that level of historical perspective becomes very important. One can look at fabric health, utilization of the fabric across various devices, and also visibility of compute and storage domains. VM names, host names, service information. For example, this one shows Kubernetes based services, all visible within the controller analytics. And so this rich visibility built into the controller-based fabric provides, sort of amazing value when it comes to capacity planning as well as troubleshooting. Okay, grand finale.
Fantastic. All right, on to sign number 7. So we are going to jump right into the poll here. So the poll question is, have you provisioned a VPC? Please select which of the following is the correct answer for you personally. Option 1 is I do not know what a VPC is. Option 2, I do know what a VPC is, but I have not provisioned one. Option 3, yes, I have provisioned a VPC. Option 4, yes, I regularly provision VPCs. And let's take a look at the results. 100% of you, yes, I have provisioned a VPC. Excellent. Don't need to do too much educating then.
Fantastic. We are in the cloud era.
We certainly are. Nothing says cloud like a VPC.
All right, so let's talk non-VPC first. Go back to our black boxes, traditional devices, and we know all the challenges that they bring with it. And so what have the cloud guys done? And they have said, forget about the infrastructure. You have no access to the infrastructure because you don't need to look at the infrastructure. And what they've provided is a different interface, a logical network interface versus a hardware-oriented interface, and in the form of a VPC or a virtual private cloud. Of course, VPC construct is leveraged, or the nomenclature is leveraged by AWS and Google Cloud. In Azure, it is appropriately referenced as VNet because it is really a unit of networking, logical networking. It simplifies, deploying L2, really subnets and L3 constructs, route tables, gateways, security groups. It's multi-tenant by definition, and each VPC can have delegated administration. So there is no, looking at hardware constructs such as devices, ports, VLANs, VRFs. None of that hardwired, hardware-oriented configuration is necessary. Now, what we did, Kate, was we went to Google Trends and said, hey, let's look at the popularity of VPC. Of course, the audience here, that's not an issue, but in general, in the world, I guess this is a US trend. What is, how well is VPC understood versus VLAN? And clearly, we see that popularity of VPC growing over the last 5 years to a crossover point now, and over the next few years, VPC is going to be the talk of the town in mainstream organizations. So how do we leverage these cloud-first principles to bring VPC on-premise? And we believe this is a fundamental shift in the way on-prem data center networks are going to be managed. Once we have VPC on-prem, now we truly have private cloud experience in the data center. And we believe this is very possible. We've seen, triple-digit customers deploy this and leverage it. And as part of a tenant-oriented configuration model, exactly like the VPC, which can also be further automated by each tenant VPC, on-prem VPC, be integrated with a variety of private cloud orchestrators, such as VMware, Kubernetes, Red Hat, Nutanix, and so on. And this can all operate on top of a cloth-based fabric that is controlled through an external controller. With this, the opportunity that we have is really when we have an existing data center, we can deploy VPCs in a brownfield environment. New data center can bring modern technologies, directly cloud-style capabilities in the data center, leveraging VPCs. The nomenclature eVPC simply represents enterprise VPC to highlight that it's an on-prem VPC. And all of this is controller managed. And certainly there is an opportunity to have a controller in the cloud to also manage VPCs in Amazon and bring visibility across the entire hybrid cloud and the ability to manage through this unified construct, which VPC can become. And so we have a lot of confidence that VPC is the right unit of logical networking that should be available in every data center deployment. Now, here is another super important power of VPCs when they're deployed on-prem. So we know when we go to public cloud and deploy VPCs, we can deploy multiple VPCs. They don't interact with each other unless VPC peering is enabled, and their delegation can be, through different administrators. The same thing can also be achieved today, and it is implemented in Big Switch's solution, the Cloud Fabric, which is to deploy a variety of VPCs, each integrated with its own orchestrator, and all of them can reside on the same fabric. So same physical fabric shared across multiple on-prem VPCs. You can have a VPC that automates its networking and provides visibility in Red Hat OpenShift environment, in Kubernetes environment, another one in Nutanix, another one with vSphere or vSAN or NSX. You could have another VPC with Mesosphere, DCOS, and all of these VPCs reside in the same environment. So this is great, for example, in engineering environment where you need to test an application across multiple different cloud environments. It's great for managed cloud offering, private cloud offering by managed service providers, as well as doing the CI/CD workflows of dev, test, pre-prod, and prod can all occur within the same network environment through VPCs and through software without having multiple siloed infrastructure. So we did an experiment a couple months ago. We had Network Field Day here at Big Switch, and what we said was that, hey, we will open up our live company network, and we'll give you a VPC and go ahead and configure the VPCs. And here are some tweets where the team started out with that, and they were like, man, no way this is this can happen. It certainly never happens on a traditional network. And here is a person, Kevin Myers, configuring a VPC in his own tenant environment. And here's a CLI version of the tenant VPC. And so very easy to provide delegated administration on an existing shared infrastructure to allow network teams, DevOps teams, to be very agile, bring speed, bring velocity, enable services at a very rapid pace, get the network out of the way. And that's really the modern way of building networks. And we think that these 7 signs together bring tremendous transformation in networking to bring cost down, make it very low cost, make it very simple to operate, make it very, very fast to provision services, automated, and of course you get tremendous vendor choice.
Fantastic. We are going to wrap it up now. We appreciate everyone for joining us today. If you do have any questions on today's webinar, 7 Signs of Data Center Network Transformation, we'd love to hear from you. Please email us at info@bigswitch.com. We make it easy for you to get started with Big Switch solutions. There are several resources you can download or watch that will give a tour of our products. In your handouts, you will find live links you can click to access any of these resources listed here, as well as resources from our panel. With BSN Labs, you can experience Big Switch Network's SDN solutions firsthand from the comfort of your home. We believe that there is no better way to learn about a product or technology than to take it for a test drive. For a free online real-time access to our cloud-first networking products, please visit labs.bigswitch.com or download the handouts. That concludes our presentation for today. We thank you for joining us, and we hope to hear from you soon.